Right, so do some 1000. So this topic here is basically kind of like a cheat sheet on dependent sources. So what are dependent sources is basically just it's like a diamond. You have diamonds. So you can have a dependent current source, or you can have a dependent voltage source. So as the word says, the value that it outputs, it depends on a value somewhere else in the circuit. So you can have a voltage dependent current source, or you can have a current dependent current source, or you can have a current dependent voltage source, or a voltage dependent voltage source, which is that's how the stuff could go. Because you can have a dependent current source or a dependent voltage source, but the values it outputs, it can either depend on the current or voltage somewhere else in the circuit. That's just keep it real simple. Right, so we're just going through like how you will handle them while you're doing questions. Yeah, that's quite a night. So you should be able to long of a video. So I'm just get my notes. So let's go. So the first type of analysis you have nodal. And if you have a dependent current source in here, so you can remember it could be voltage. It depends on the voltage or it could depend on the current. So this one here is if it have a dependent current source and it currents dependent. So if it current dependent, so the first way you can have a resistor. So always look at your polarity, which they should give you. So if current flowing in this direction, through the resistor we expect to go from a plus to a minus, because current does naturally flow from a high to a low. This pattern never changes, right? You wouldn't see current flowing so, because that means it's going from a minus to a plus. That does not make sense. So what we will have nodes on both sides of the resistor, because it's nodal analysis. So you'll have a node here and you'll have a node here. So if we label this, or if you label this node whatever it is, in this case I'll label this one VB and this one VA. The currents I0 will be where you're coming from in terms of the current minus where you're going to divided by the resistor in between. So you're coming from this node, going to this node, and you divided by the resistor that is in between it. So the other way it could come is if they ask you just for the opposite. So basically they give you the resistor. So this is still VA and this is still the VB node, but now the current flowing this way. Right? So it will basically be the reverse direction. This is I0 and same thing. So you're coming from VB and you go into VA and you divided by the the resistor value in between it. So same concept, just went to the in another direction. So that's how you will do the current dependence. So when it depends on the current, these are how you will get it. Okay? So the other way is same nodal. You can do the yeah, so nodal analysis. Second way is the when it voltage dependent. And the voltage dependent kinda easier because it's basically just the current dependent just without the R. if you notice. So the first piece, so if you have VA here and VB, so down middle give you arrow to tell you the polarity, so minus to plus. So always observe the circuit. It should give you what that is. So in this case, the voltage drop is denominator will say V0. So V0 will end up being VA minus VB. Same concept as before, right? In this case, the current will be flowing in this way, but we care about the voltage, not the current, okay? The other way kind of is just the opposite. So this is VA, VB. So now they're invert the polarities. So now the voltage drop the ones is this, and obviously the current flow in this way. So the same concept as reverse. So V0 will be where you're coming from minus where you're going. And that's so you're just looking for the patterns. Okay. Well, the next one for nodal, we have a dependent voltage source. So when I give you a dependent voltage source, it doesn't matter which one it is. What it depends on is what value it's looking for. Is it looking for a current or it's looking for a voltage? So you can have a current dependent current source because it depends on the current. The current source depending on the current somewhere else in your circuit. And you will know because they'll give you a label so you'll know where to go, whether it's I0 or whatever the case is. Or you could have a voltage dependent. So the current that coming out of here depending on the voltage somewhere else in the circuit. So that's how you will analyze these. So the trick, these two, it's not gonna be different for this. So we could basically just write this here. So the trick, first thing you have to do is you draw or obtain. Okay, you should be able to have it, the current direction. And well, always remember the true resistor is always from plus to minus. That's how the current does flow. The voltage, however, or the voltage rise was in the opposite direction, which is V0. Okay, so this pattern here you will see it everywhere, no matter what you're trying to do. And the next thing is you just look at the cases we have. So we have case one, which is the current dependent, and case two, which is the voltage dependent. The same idea. Right? So once you have your polarity, is always where you're coming from, minus where you're going. The pattern is always the same. And this here is based on your current direction. Once you have your current direction, you basically get through. So I just run it through one more time. So for nodal, if you have a dependent current source or voltage source, no matter which one it is. For the currents, you look at your polarity, your current, your direction, so plus to minus. So this is a current dependence, they will tell you the current they're looking for. So if they tell you the current, you will know the direction it's going in. And if you know the direction it's going, you will know the plus of the resistor and the negative of it. Because current could only flow from plus to minus, right? High to low. So since you have that, same rule. So we're coming from, remember it's nodal analysis, so you'll have the nodes on both sides of the resistors. So you're kind of using that. So in this case, it'll be VA, we're coming from, minus we're going to. And since you want current, you have to divide by R. And same thing if it does reverse here. So the one current going in reverse direction, it would just be VB and VA. Where you're coming from, minus where you're going, divided by the resistor in between it. Then you have a voltage dependent source. So if it depends on the voltage, it's basically just on top here, but you're just not divided by R. So same pattern, I0 going in this way, obviously the voltage can rise in this direction. If they want this view, same concept. VO where you're coming from, this is where the current minus where you're going to. And if we reverse it, this is basically just this backwards. But in the circuit, they might label it as this, right? So if they want V0 here, everything here perfect. So it'll be VB minus VA. Alright? So that is it for the nodal analysis. So now we could do it for the loop. So let's reload the page. This should clear up. Let's go again. So loop. Do like this length of this. So your loop analysis. Same as before. So you can have the voltage dependence. So let's just zoom in a little bit. So let's go and draw a simple diagram on both of them. So the first way, I0 going down. So we have the R plus the minus, we know this for sure. And then you have, normally you could have two currents, so for now just use the two, just to make it a little complex. If you don't have a current or any branch, it's just one current, you just use that one current, right? Because obviously the other one will be zero. So in this case now, the voltage V0, okay, remember the voltage will be here, minus the plus will be R I1, well, in this case it will be I0. I0 minus R I1 is equal to V0. Okay, so why does it make sense? So Ri0 is on the positive side, so it's positive. That's to keep it simple. Subtract Ri1. So since this direction here is positive direction for the current, any current that going in the negative direction will be negative. Obviously, you're seeing it on the negative side of the resistor. So boom. And that is basically V0. I by R is voltage. So what you're technically doing here is where you're coming from, the voltage we're coming from, minus we're going to, but in this case, no matter the current, it won't change, which is equal to the voltage drop. So it's literally the same thing as nodal analysis. It's just you're dealing with currents now, because that is where you actually will calculate for when you're doing loop analysis. Okay? And then, well, this one is basically the same idea with just the voltage invert. So I0 still here and I1 still here, but now the polarity has swapped. So now the voltage going this way. So same concept. So we need to pick the current. So obviously it'll be I1 will be positive because it's on the positive side and going here. Remember this is a voltage drop and current flows from I to loop. The same concept we use over and over. Right? So in this case, the equation for it will be, remember it's R here. So it'll be R I0, well in this case I1, and then on the negative side it will be minus R I0, and that is equal to V0. Very simple. So the positive side, and then negative side. Where you're coming from, minus where you're going. Same concept. Once you have the current direction, the positive current direction, that is, you get through. And what we could do when they're looking for currents, so current dependence, let's do so loop analysis. So the last one we have is your current dependence. So on its current dependence, so they're over the same two. So we have I1, so I0 flowing through here, and you have I1 flowing up, and we have R. So in this case, they will look and see which current they want, but just to keep it simple, if they want the I0, which is flowing in this direction, so since I use I0 and I1 here, I'll just use I2. So if they want I2 that is flowing in this direction here, in the branch you'll notice you have two currents, one current going down, one current going up, but you always have a positive direction. Why? Because I2 here, what they give you is plus to minus, remember that, right? And in this case, the current that in the branch that going in the same direction is I0. So it will be the same concept. So I2 will basically be the current with minus the current against. See, the same concept. I1 on the negative side, I0 on the positive side. But you have to use this to give you the actual polarity across the resistor to know which side is the positive and which side is the negative. And the other way. So I1, I0, but now they want the current going this way. So same concept, this will be positive to minus. And because we have that, I1 will be in the current direction for I2. So I2 will be with minus against. Okay, and that basically all this. That's basically all. So for loop and nodal. So go through, look for the patterns, and once you remember the patterns, you can just rinse and repeat them for everything else. Alright? So later.